5.2, addition and subtraction of rational expressions. So we learned what a rational function was, so which means we can look at an expression of those. So today we want to be able to start adding and subtracting with those and see how we can work with some of those pieces. Okay. All right, so let's just hop right into their examples. There are no definitions. Again, we want to simplify. So number one, x minus 2y over x plus y plus x plus 9y over x plus y. All right, now hopefully we remember that in order to add fractions, so if we just forget about the variables for a moment, think about numbers, in order to add fractions, we have to have a common denominator. So that's what we want here. Even when we have letters, we want a common denominator. So we look for that first. So here when I look at these, I have an x plus y and I have an x plus y. We have a common denominator. Well, that means I can add the tops and my denominator stays the same. So when we're looking at this problem here, go ahead and draw this. I'm going to put x plus y. I kind of elongated that. It's not a big deal there on those pieces. So just if I don't need it, I'll erase whatever I don't need. Okay. All right, so let's add. X plus x is 2x. Negative 2y plus 9y is a positive 7y. Okay? So I didn't need all that fraction there for those. Now I do still need to look, just like I did in 5.1, can I factor this? Can I reduce it? Well, here we have 7 and 2. Those do not reduce, and then x and y. So I can't factor anything out of the top. These are not the same. So here is my result. Okay? So we need to look for that every single time. All right. Let's see, number 2. Y minus 2 over y plus 4 plus y minus 3 over y minus 5. Okay. Now we don't have a common denominator. So we need to make one. All right. Now, if again we were to go back to numbers and say we had a denominator of 2 and a denominator of 3, we would find our common denominator by multiplying those two things together. 2 times 3 would give me 6 for those. Okay. We're going to use that same kind of concept here. Now, it's probably a good idea before we do all of that, anything that has a plus or minus, we're going to put in a parentheses here. All right, it just keeps it all together. It keeps us from making mistakes. So you really do need to do that because we're going to be multiplying pretty much every one of these things as we move forward. Okay. All right, now what we want to do is we want to make these denominators the same. So here I have a y plus 4. Well, I need one over here. So I'm going to put y plus 4 on the bottom. And whatever I do to the bottom of this fraction to keep it the same, I have to do to the top of that fraction. So now they both have a y plus 4. The overall is not the same. This one has a y minus 5. So it needs one over here. Okay. Now, I highly recommend that we rewrite the problem first before we start doing any math. I'm just going to put all of the top together over one big y plus 4, y minus 5, or vice versa. If you want to put the minus 5 first, that is just fine. Okay. All right, so now I'm going to multiply this stuff out and then I'll combine like terms. So here I'm going to get y squared minus 5y minus 2y plus 10. So all I've done here is multiply these first two out. Plus, and because it's a plus, we don't have a big worry there. We can just go ahead and multiply out y squared plus 4y minus 3y minus 12. Now the bottom, I am never going to multiply out that bottom. I am hoping that after I do some of this math, that maybe I can factor the top and it's going to eliminate with the bottom for those. So since that's going to be the hope, I'm never going to multiply with the bottom. We don't need to do that. All right, so now let's combine like terms. So we have a y squared and a y squared. So that's 2y squared. We have -5, -2, that's -7, plus 4, that gives me what? -3, minus 3, which is -6y. Right. Then we have 10 and -12, which is a -2. All right, now we could try to factor the top. We could pull the 2 off there, but it's not a big deal because we won't be able to factor the trinomial for those. Even if we try with those, it won't happen. So since the top is not factorable in a way that's going to benefit me to eliminate with the bottom, we are done. So we can leave it there for that one. Okay, but if I can factor that top in a way that will eliminate with the bottom, I need to do so. So look for those things. In this case, even if I factor the 2 off and put it out in front, that's fine. You can do that. You're going to see that the trinomial does not factor. Okay. All right. 3. 4xy over x squared minus y squared plus x minus y over x plus y. Okay. All right. So in our previous problem, we had a y plus 4 and a y minus 5. Those were already in their lowest terms, so we could start going out and putting those things together. But here on this one, it's a little bit different. We see on this, I have an x squared and a y squared, and we can actually factor that. So if you can factor that denominator, we need to do so. So I'm going to do that in red here, so I don't have to write this problem a whole bunch of times. So instead of this reading x squared minus y squared, I wanted to read x plus y times x minus y, because it's a difference of squares. And that's what I'm going to use instead of the x squared minus y squared. Well, now that helps me because that gives less over here to be the same. Okay, and so let's look at that. Now I'm going to go ahead and parentheses off all these other things like I did earlier. So this one has an x plus y, and so does that one. This one has an x minus y, so this one needs an x minus y. Okay, so now those denominators are the same. So let's rewrite the top, 4xy plus x minus y times x minus y, all divided by x plus y, x minus y. Okay. All right, so let's multiply out there. So 4xy plus, we get x squared minus xy minus xy plus y squared, all over x minus y, x plus y, or vice versa. On our like terms, so we're going to get here, I'm going to put it in order of x squared, then I'll put all of these together. So 4 minus 1 is 3, minus another one is 2xy plus y squared, which should look like a 2, and then x minus y, x plus y. Okay. Now we need to see, can we factor that bottom piece? Now, as we get better, you might not have seen this before, but we can. And one way to recognize we can here is, or at least try. Notice here I have x squared, then an x, and then no x. But over here I've got y squared, then y, and then no y. If we have that pattern, we can at least attempt to try to factor this. Okay, so let's do that. I need to move up a little bit higher here for this. right, so let's just put our equals, let's put our bottom, x minus y, x plus y. And it's a trinomial. Their signs are the same. They're both plus. So what gives me x squared? It's x and x. What gives me y squared is y and y. Now, if you do your check on that, you will see that you do get 2xy in the middle. So we did factor that correctly, okay? Now, since we factored it correctly, we can see there's an x plus y and an x plus y on top and bottom. So they reduce. And so we end up with a final answer of x plus y over x minus y. Okay? So those are things that we want to look for on all of these problems. All right, we've got a couple more. These are long problems, so I'm going to have to erase what we have up here. And part of the longness of them is just that there's a lot of little things within it. Okay, so as I'm looking at those, we're not doing a lot of stuff at once, so we have to be careful there on those pieces. All right, so number 4. 3x minus 1 over x squared plus 2x minus 3 minus x plus 4 over x squared minus 9. All right. So here I am going to do this one where I'll go ahead and rewrite the problem to factor it because we just have so much going on. I don't want us to get confused. So let's do that. So my top is not changing. So 3x minus 1. But here I need to factor. So that's going to become double parentheses plus minus x and x, and it looks like 3 and 1. And then over here, we still have the x plus 4, but I'm going to have x plus 3 and x minus 3. All right. All right, so I have an x plus 3 and an x plus 3. Move that over just a little. I've got an x minus 1, so this one needs an x minus 1. Okay, so those are the same. Now I need the x minus 3 over here for those. Okay, so now those two things are the same, so we can begin to work on those. All right. Now, again, we want to be very careful here. I am going to go ahead and multiply these things out, but I want to keep them in parentheses because I've got this minus sign right here we've not had before, and we got to be very careful and make sure we distribute it properly. A lot of times I see if we try to do too much at once, we make mistakes with that sign. So let's make sure we do it correctly. All right, so let's go ahead and multiply this top out. We're going to get 3x squared minus 9x minus x plus 3. So that is that first one here. And then my second one, I'm going to get x squared minus x plus 4x minus 4. And on the bottom, we're going to get x minus 1, x minus 3, x plus 3. The order there does not matter on those. Just as long as you have each one of those represented, you're good to go. All right, so now we want to distribute this negative here. So I'm distributing, and then I want to combine like terms afterwards, okay? So I'm just going to rewrite the top here. We have 3x squared minus 9x minus x plus 3, and then minus x squared plus x minus 4x minus 4, and then x minus 1, x minus 3, x plus 3 on the bottom. Again, we're never multiplying out that bottom, so we want to make sure of that. All right, let's combine like terms. So here I've got 3x squared minus x squared. That's a 2x squared. Also do notice I have a minus x and a plus x. Those kill each other. So negative 9x minus 4x is a negative 13x. And so I've got those. And then we have 3 minus 4, which is a negative 1. Actually, that was supposed to be a 7. I made a mistake there. Getting too fast for myself. I did this one correct, but I did this one wrong. That was a plus 4. So you can see where you start moving too fast. It's really easy. This should have been plus 7 for those. Okay, pieces. Now, we would want to try to factor that top, but we would see that nothing comes together to give me that 13 on those. Okay. Because we'd end up with a 14, we need to add those pieces that give us 14. Nothing's going to come out of 13. So the top is not factorable. I do want to try, but since it's not factorable for those, this is our results. Okay. All right, so again, as you can see, you need to be careful with a lot of little things. Even I almost made a mistake there, getting ahead of myself, trying to work too fast for those. Slow yourself down just a moment in these problems. All right, let's do one more. Your longest problem of all of our pieces here. And let's see what we have going on. Number 5. X minus 1 over x minus 2 minus x plus 1 over x plus 2 plus x minus 6 over x squared minus 4. Okay. All right, so again, I want to rewrite this, factor any pieces at the bottom that I can, and before I start doing common denominators. X minus 1 over x minus 2. I'm assuming here I'm probably going to have to multiply, so I'm going to leave a little space. X plus 1 over x plus 2. Again, same type of thing. I'm going to leave a little space because I see I'm going to have to factor this last one. X plus 2x minus 2 and x minus 6. All right, so this one has an x minus 2. This one does not. So it needs it. So we're good there. And that one has an x minus 2. This one has an x plus 2. So does this one, but this one does not. So now we have it. And now all of our bottoms are the same. So we can go from there. All right, so again, I'm going to multiply these out as I move down to this next line, but I want to keep parentheses, especially because I have this minus here. If I had plus and plus, I wouldn't worry about the parentheses. But because I have that minus, I need to make sure that I distribute it properly. So I'm going to go ahead and put things in parentheses. So for this first one, I'm going to get x squared plus 2x minus x minus 2. There's my minus sign. You get x squared minus 2x plus x minus 2. And then plus x minus 6. And then on the bottom, we're just going to get x plus 2, x minus 2. All right, just checking my work real quick. A lot of places we can go wrong there. So I'm just making sure that I did my signs correctly. Okay, so I've checked my work. I'm pretty positive I didn't miss anything. So now I need to distribute this negative, and then I'll combine like terms. So my first one, x squared plus 2x minus 2, and then minus x squared plus 2x minus x plus 2, and then plus x minus 6, all divided by x plus 2, x minus 2. All right, now one of the things you may want to start doing is trying to go through and see, does anything eliminate here? So I have an x squared and a negative x squared. I have a negative x and a positive x. I've got a negative 2 and a positive 2. So those all help me eliminate a little faster. I don't have to add and then subtract them from those, okay? So let's go back and combine anything. So I've got a 2x here. Those are eliminated. A 2x and then minus an x. 2 plus 2 is 4. Minus 1 is 3x. Everything else all the way down to the 6, so minus 6. And so just like that, I've got a much smaller compact problem. Now we still need to see, can I factor that top piece? This time I can. I have a 3 in common. Well, that allows me to see I have an x minus 2 on top and bottom. So we were able to bring this down to just 3 over x plus 2. So I was able to take this large problem through the magic of math and get it down to this single fraction that's pretty small and compact. Okay? So those are the things that we want to look for here when we're getting these pieces together for adding and subtracting rationals.